Leah, there are two famous applications of vectors. One of them I've already snuck in with you, and that was the airplane being blown sideways by a crosswind. And the other one is the famous river question, a boat going across a river being pushed downstream by the current. The physics is going to be very similar. In fact, the equation that we're going to use, and if you wanted to, you could kind of write this at the top, is it's going to be the engine velocity plus the wind velocity or the current velocity is what gives you the velocity with respect to the ground. That equation I did put on your formula sheet. So let's look at one here. It says this. An observer is standing on the shore of a river which flows to the east. I see compass directions. I'm going to do that because now I feel better. I've written something down. He sees a boat traveling across the river. The boat is pointing due north, but the current gives a resultant velocity of 8 meters per second, 65 degrees north of east. What does DOLP stand for? Okay. Here's my river. Brian, which way is the current flowing in this river? I'll draw a little arrow over here pointing to the east, and I'll call that V. Instead of W for wind, how about C for? Yeah. Now let's talk about the boat. The boat is pointing straight up. Don't write this down, but can you use your imagination? Can you see if the boat was pointing straight up? It's going to get pushed sideways by the current. It's going to look like it's kind of traveling that way to those of us that are watching on shore. In fact, what's the resultant velocity, Brian? Can you read it to me, magnitude and direction? North of what? North of what? North of what? East? North of what? North of what? I'm going to draw east first, and I'm going to go north of east. I think it's going to look like this. Yunk. Like that. I think that is 65 degrees north of east. How long is that vector? How long is that vector? How big is it? 8. Okay. All right. I've dolped. I'm going to play around with the triangle here a little bit in a second, but okay. What does A want me to find? Now this 8 is the resultant, so I'm going to draw it over here. And I notice there is an angle of 65 degrees. Did I say angle? You know what this is a job for? Components. Oh, if I draw this component in, normally I would call that Vx, but look at my picture. What velocity is causing that actually? That's the current. And then I have another vector going this way. You know what? I think that's the engine. The motor is pushing it north. So when it says, how fast is the current? What it's really asking me to find is, it turns out, a component. Brian, that 8, opposite, adjacent, or hypotenuse? What about the current? Which trig function? It's going to be cosine of 65 is current divided by 8. Cool. So by measuring the angle that the boat is traveling at and the velocity the boat is traveling at, I can tell you how fast the current is going. You get 3.38? Since this is a final answer, I'll go to 3 sig figs. And that's actually not too bad a place to round off to. It's technically 3.381, but 3.38 meters per second. East. Evan, what's B asking me to find?
How fast the boat's moving across the river.
Isn't the answer 8? Not directly across the river. What's it in my picture asking me to find? Yeah, the engine velocity. That's what's pushing it straight across. I know it's moving sideways, but in terms of crossing the river, it all depends on the engine velocity. Which trig function?
Sine.
Oh, cool. Almost the same trig as before. I think I could just backspace and change the sine to a cosine conveniently, and I get 7.25. And you know what? There's a 0. That's probably a good place to round off as well. Meters per second north. Now we can answer some questions. If the river is 256 meters wide, how long does it take to cross the river? What's this asking me to find? Well, let's write down T equals question mark. For the river question, for airplane question, although we could handle it, you can assume that the acceleration is 0. We could handle an acceleration, it just unnecessarily complicates things. And typically airplanes don't speed up and slow down, they go at a constant speed. And typically when you're in your boat, once you hit your cruising speed, you just keep it there. You don't speed up, slow down, speed up, slow down, speed up, slow down. Let's go back to my picture here. 256 meters, let's add that to the DULP. I think that's going to be right there, 256 meters. You could have also put it like right there or wherever, but I tucked it off to the side. What equation could I use? Got a T, I've got an A, I've got a D. Is there something that I could use to find a T here? Oh, I also have a whole bunch of V's. Which equal? Plus what? What's A? I can use, and in fact, to get the T by itself, it's going to be that. Yes? Mateo, what's D? And here's the real question. Which V am I going to use? Am I going to use the 3.38, the 7.25, or the 8? And here is the key rule with vectors and the most common mistake kids make. If you're doing physics with vectors and direction, everything in the equation has to be in the same direction. So see that 256? See how I drew it? Which is the only velocity that's parallel to that 256? I'm going to give you a hint. It's not 8. Right? That's the one you're going to see me go cuckoo over. Later on, when we're looking at projectiles, we're going to break everything into a horizontal and into a vertical component. And the most common mistake and the biggest sin is people will put a horizontal value into a vertical equation, or they'll put a vertical value into a horizontal equation. Specifically, they'll want to use A equals negative 9.8, which is gravity, and they'll put that into a horizontal equation. And I'll snap and say, no, gravity doesn't act sideways. Gravity acts down. So, if you want to give yourself a little hint, put a letter Y for vertical, letter Y for vertical, because another way to think about north and south is as vertical. and it's going to be y and y, and so it's going to be 7.25. 256 divided by... You know what? I still have this on my calculator, so I'm going to use my answer button. And I get 35.3 seconds. Good stretch, Hannah? Yep. What's D want me to find? Oh, I love the way she said that. Did you hear her? Horizontal distance. In fact, let's cleverly say dx equals question mark. I like that. Again, for all of these, we're going to assume that, which means we're going to always be using, for now, that equation, except you'll notice I put an x there too, and that's the key idea. We have to use a horizontal velocity for a horizontal distance. I don't know time. Or do I? Yep. 256.
Oh, okay.
Yep. And that's not your fault. You tried reading my hideous writing, probably. Hannah, how would I get the d by its... Oh! Ha! So the time I'm going to use is the 35.3 seconds. But the real question, Hannah, which velocity am I going to use? I'm going to give you a hint. Not the 8. More specific. More specific, as a number. No, that's not what I wrote. Why would I use a rounded off to 2 sig figs answer that had error in it and then introduce even more error to mine? I'm at least going to use, I wrote 3.38 because there was a 0 after the 8, and I said something like that's a good place to round off. If I really wanted to be fussy, I would use 8 cos 65, store that on my calculator, but I'm going to use 3.38. And I'll use my answer button for time because it's still stored there. Into 3 sig figs, Hannah, I'll go to 119 meters downstream. Okay. Here, I gave you the crossing distance. We use that to find time and figure out the drifting distance. I could reverse this. I could tell you how far downstream you drifted. If you knew this distance, could you find time? And then from that, could you figure out what the crossing distance was? In other words, can I reverse this question, Martin? As far as I'm concerned, yes. And that will be the case all year long. E says, what's the boat's engine velocity? I didn't leave you much room here on purpose because you already know the answer. What is the boat's engine velocity? And again, not 8. We actually figured that out when we found the vertical component. I think up here, I just said how fast is the boat moving across the river, but I used the subscript of, you know what, what's pushing it across the river, Brian? The engine. So that's the engine velocity, 7.25 meters north. This gives us, meters per second north, or whatever direction. This gives us the really interesting question. In real life, Evan, if you're crossing a river and you know it's pushing you east, you don't want to end up 125 meters downstream and have to hike your way back. In real life, what you would do is you would point your boat into the current so that the boat was pointing that way, but it would move straight across. It would look a little strange because the boat looks like the boat is kind of crab walking sideways across the river. That's what you do. So here's the question. If I want to end up directly across from where I started from, I don't want to have to go on a big walk. What angle do I point the boat at? And how fast will I travel across the river? So, suppose you want the boat to land directly across from its starting point. What direction would you point the boat in order to travel in a straight line due north? Can you see in that? Let's do a quick sketch again. We're definitely going to point it into the current. This is going to be the engine velocity, 7.25. The current is going to push it, so we're still using the equation that we wrote at the very, very top of the page at the beginning. We're still using V engine plus V current. So we're going to add the current to this. How do I add two vectors together? Draw them. So put your pencils down and watch. There's the current. Don't write that down, because I drew that wrong. I have an advantage. I know what the resultant is supposed to look like. The resultant is supposed to point due what? Okay, this is a little unusual. This is the first triangle that I've given you where the resultant is not the hypotenuse. This time the resultant is one of the legs. This is the hypotenuse. So watch, I'm going to start drawing the current. Tell me when I have to stop drawing it. And that gives me, I went a little too far. About there. And that gives me a resultant due north. What was the current? I've forgotten. No, what was the current? Hannah, what was the current? It was 3.38. So let's put the 3.38 right there, and let's put the 7.25 right there. Theta is going to go where the vector is originating, because this is V with respect to the ground. How can I find theta? I'm going to give you a hint. It's not tangent this time, which it's almost always been to find theta. 3.38, opposite, adjacent, or hypotenuse? Opposite, hypotenuse. Which trig function were you going to suggest, Leah? That's how we did this. We said VE because they are added right there. See it tip to tail? Okay, looks a little weird. This is our first triangle where the resultant isn't the hypotenuse. It'll usually be the hypotenuse. But in this case, because I knew what the final answer had to look like. By the way, the more interesting question, which I think you'll do in your homework, instead of a boat going across the river, if you're an airplane and there's a crosswind and you know you want to fly due north because that's where the city that you need to land is, what angle do you point your plane into the wind? And this is what they do all the time. Now they use software to figure it out. I'm sure it's all computerized, but you used to have to calculate this by hand. And the better you were at it, the less fuel you would use, the more money you would save for your airline. Oh, pilots took that very seriously. Absolutely. Oh, and the flight would be shorter. I was a little closer. Instead of a 2.5-hour flight, it was a 2-hour and 15-minute flight, saving 15 minutes of airplane fuel. I'm betting that's probably $300,000 or $400,000 you've just saved the airline, right? So, theta sine equals opposite over isn't that opposite?
Oh, sorry, I'm using the two from the sorry.
And this one.
Yeah, I was using the VE and VG.
Don't know VG yet. I'll find that in part B though. $27.8 degrees. North of south, east of west, what of what? Nice lines finish last. The nice line is of north. Yeah. Yep. B. What will the resultant vertical velocity be? I have all sorts of options to find the missing velocity. I could use trig. I think I'm going to go with Pythagoras because I can do that in my sleep. However, are we finding a hypotenuse here? So it's not going to be this squared plus this squared equals that squared. It's going to be hypotenuse squared minus that squared equals ground velocity squared. .41 meters per second. And if they wanted a direction, I could say, hey, due north, because that's how I set this up on purpose. Now I could even ask, if the river is 256 meters wide, how long will it take to cross? In other words, I can branch off into other questions as well now. There's a lot you can do with the river current pushing a boat sideways, or with the airplane wind pushing a plane sideways question. They're the same question. Handy hint, if they give you a vertical distance, dy, use vy to find t. If they give you a horizontal distance, dx, use vx to find t, and turn the page. Good yawn? Oh, it's on, Chantal. An observer is standing on the shore of a river that flows to the east. He sees a boat traveling across the river. The boat's velocity on the river is 12 meters per second, 55 degrees north of east. The boat is pointing due north. This is a clone of the question that we just did. So if you feel like you want to work ahead, you can. We all just turned the page, so I'm going to stick another compass rose on there. The boat's velocity is north of what? East. North of what? East. North of what? East. Start out going east, go north of east, yoink. 12 meters per second, and this is 55 degrees. Brian, if you wanted to, you could do your component triangle right there. I usually draw the river here and then do the trig here. I don't know why I picked up that habit, but I almost always redraw the triangle kind of uncluttered away from my artwork. Maybe it's because my artwork always sucks and creeps me out. Okay? So, 12. Now, I could call this, don't write this down, Vx and Vy, but relative to the river, what is Vx actually? Yep. Now, this is for an east-west river. If there was flowing north-south, then the current would be vertical, and Vy would be the current. I don't have to always give you an east-west river. And we said that this was the engine velocity. How fast is the current? Adjacent, hypotenuse, cos 55. You get 6.88. I might, Hannah, even jot down in the margin somewhere 6.883 or 6.8829, just so that I'm using extra sig figs, not fewer sig figs, because that was an egregious error. Using a rounded off to 2 digits, we're going to be way off in our later answers, because we're going to be using that to find something, to find something, to find something, and it's going to multiply through. Yes? But I'll go 6.88 meters per second. And again, this one is east. And I think the engine is going to be which trig function? Which trig function? So I'm going to take a gamble and a shortcut and just, without writing anything down, say, hey, I'm pretty sure it's sine. Oh, 9.83. That's a pretty good place to round off because it's almost exactly 9.83. And that's north. This boat must have a slightly bigger engine than the previous question. If the river is 320 meters wide, which would go right there, how long does it take to cross the river? So again, we're finding time. We're using d equals VIT plus a half AT squared, but I'm not going to give you a question where we have an acceleration. We could deal with it. We did do a question at the very end of last day's lesson where we had an acceleration that was in a different direction from the velocity. We used VF equals VI plus AT. We added stuff tip to tip. You know what, Darwin? We could handle it, but meh. Darwin, how would I get the t by itself? And the key idea, it's going to be dx and vx. Oh, no, wait a minute. The distance in my picture isn't horizontal, it's vertical. So I'm just going to make a little note. Make sure I use the vertical velocity, which is not going to be the 12. In fact, you'll notice once I go components, do I ever use the 12? No. It's going to be... in the same direction as this? By the way, I'm glad you made that mistake. That's the most common mistake. Let's not do that again, right?
32 points.
First of all, it's going to be 320 and divided by 9.83. This is almost 320 divided by 10. So this should be an answer really close to 32. What did you say, Ibrahim? Is that right, folks? So we'll go to 3 sig figs. You know what? I'm going to do that because I know I probably want this number stored on my calculator anyhow. So I'll write 32.6 and I'll store this number on my calculator. How far down the bank will the boat have moved when it reaches the far side? So now it wants us to find that distance. Okay. Good, lots of time. VX. Leah, what's VX? Yeah. 6.8 even? 6.88. Let's round out. Yeah, and that was, it was a 0, or no, was it a 3 after? You know what? I'll use the 6.88. But I could always, if I'd forgotten, quickly recreate it because I could always go, it was 12 cos 65. In fact, if I wanted to be bang on, I could go 12 cos 65. That's exactly 55. Thank you. That's exactly VX. And then I could go times answer button. That's exactly T time. If you really want to be bang on, you can actually just retype the expressions into your calculator. I figure if I keep 4 or 5 sig figs, that always gives me good to 3 sig figs, and I'm not freaking out too much about this question here. So I'm going to go divided, no, not divided by Mr. Dueck, 6.88 times answer button. I'll write Ibrahim 32.6, but I'll store that number on my calculator. Do you get 224 meters? What's the boat's engine velocity? Conveniently, we already figured it out. The engine velocity was 9.83. I love it when people try to out-nerd each other. And now let's do the interesting question. Because in real life, you don't want to end up 224 meters downstream and have to slog your way back. You might not even be able to make it. Maybe the beach doesn't let you walk all the way along the river. Maybe that would require you to hike in the woods or something. So instead, you're going to point the boat into the current. Let's dolp down here. So here's my river again. We're going to point the boat that way. I don't know at what angle, but I definitely know it's up and left because the current is pushing me to the right. How big is that magnitude? That magnitude is 9.83, which was the engine. What's the other velocity that I'm going to add to this? The current. How do I add two vectors? Draw them tip to tail. Now, we're not adding two vectors to get a hypotenuse, but I do know what the answer is supposed to look like. I want the answer to look due north. Tell me when to stop drawing. In my triangle, tell me when to stop drawing. And that's going to give me a resultant due north, and here is the current. What was the current? Was it 6 point something? No, 6.88? And so I can find the angle theta, which goes in the bottom right. Why in the bottom right? Because that's where my resultant is starting from. And I can find it by going sine in this case. By the way, if the river is flowing north-south instead of east-west, I think all your trig functions will swap to the opposite. A cos will become a sine will become a cos. I think, but anyways, you can't just memorize, oh, I know that it was always sine to find that. No, it might not be. Depends on the situation. So we have for part A, sine theta equals opposite over hypotenuse. Shift sine is going to be 6.88 divided by 9.83. We have to point this at a 44.4 degree angle. North of south, east of west, what of what? This is also west of north. And if we wanted to find the magnitude, I'm going to use Pythagoras again. So I'm going to go 9.83 squared, take away 6.88 squared, square root, just above 7. Because the square root of 49 is 7, square root of 49.3, it's probably going to be like 7.0 something. Yeah. 7.02. 7.02 meters per second north. I didn't do an airplane with a crosswind, but can you use your imagination, David, to see how I could easily adapt this over? Where would the wind be? The current. Where would the engines be? Still the engines, and your ground velocity is the ground velocity. What's your homework? Again, I think you'll probably have to do these on a separate piece of paper. I'm good with number 1. I'm good with number 2. I'm good with number 3, 4. Yeah, I'm good with all of 5, 6. 7 is good. 8 is good. 9 is good. Okay, that's a lot I'm throwing at you here, so let's see what I can shop. You know what? I'll let you skip number 2. And number 1 you can probably do in your head. I'm gonna skip 5A and 5B. I'll skip 6. Okay, but definitely 7. There's an airplane question. 8 is good. 9 is good. 10 is good. 11 is good. 12 is good. I'm going to nuke 13. I'm going to skip 14. 15 is good. 16 and 17 are good. Throwing a little more homework at you today because we really need to practice some applications. So what did I end up skipping? I think I skipped 13 and 14. I skipped 6. I skipped 5A and B, and I skipped number 2. I think you probably need to do these on a separate piece of paper if you're going to do good pictures, unless you write microscopically small, and if you really choose to, I mean, go ahead, I guess. Number 15 is conceptual. I'm curious to see who's really wrapped their brain around what's going on. Use your imagination, puzzle this out, see what you think would make sense, and if not, I'll talk about these next class. Okay?